Let's continue with problem 25, and let's do the part F now against 25F in Siegel's page 92. These problems ask what's the pH of various solutions, and all the solutions are 0.2 molar. In this particular case here in the letter F, the solution is a solution of ammonium bromide, NH4Br. So when you look at the salts, first we examine where the salt comes from. It comes from a strong acid, HBr, and it comes from a weak base, ammonium hydroxide. So what's important for this problem here is ammonium hydroxide. So we're going to get the Kb for ammonium hydroxide. The Kb for this is 1.8 10 to the negative 5. So Br minus is not going to undergo hydrolysis, but NH4 plus it's going to undergo hydrolysis. So let's start it writing the equation. NH4 plus water in equilibrium with NH4 OH plus H plus. So again, the same principle. We had 0.2, and a little bit of it is going to be reactive water, and it becomes sodium ammonium hydroxide. So the same amount that was reacted is going to be produced in here and in here. All right. So now we know that this the Ka, and what's the Ka would be concentration of ammonium hydroxide times concentration of H plus divided by the concentration of ammonium. It's the conjugated acid of ammonium, right? So let's plug in the numbers here. We know the Ka because we have Kb, so it's the same thing. We know that Kw is Ka times Kb. Therefore, we can calculate Ka equals Kw divided by Kb. Kw, we know that's a constant, 10 to negative 14, and the Ka is Kb, sorry, is a 1.8, 10 to negative 5. So from that we get the Ka equals 5.56, 10 to minus 10. That's what I got here in my calculator. Okay, so let's move this thing a little bit up here. And continue with the solution of the problem. Then we have now that Ka is going to be equal concentration of ammonium hydroxide, that's X, concentration of protons, that's X, concentration of ammonia is going to be 0.22 minus X, and this is equals 5.56, 10 to minus 10 to negative 10. Same principle that we had before. We know that this is very small, so therefore we can simplify, make this 0.2. Therefore from here we can take it that x squared, x times x, equals 0.2 times 5.56, 10 to the power of negative 10. Let's calculate that now. And this is going to give us x equal 105, 10 to the of negative 5. All right, so this time here, X is the concentration of protons, right? So therefore, we can, from this, we can calculate the pH of the solution, right? The pH of the solution is going to be minus log of the concentration of H plus, which is 105, 10 to minus 5. So therefore, the pH is 4.97. Okay, very similar to the other problem. The figures may change a little bit because of the use of the calculator. However, it's approximately the same, right? 4.97.